I apologize. I wore the headset yesterday, and then at the end of the day, when I went to upload to YouTube, I realized that I wasn't actually plugged in, and so video of just it's kind of lame. Sorry, rookie teacher, right? Only 24 years. Yeah, exactly. Today I'm going to have it done, so hopefully this audio is being recorded. So we're going to look at some harder problems today. I call them the Fred and Barney style questions, but it really doesn't matter what you call them. They are two objects arriving at the same space. Hello?
You didn't share your desktop.
Oh, okay. I thought I did, but let's see. Maybe I turned it off somehow. How's that? It's coming. Yeah, I got it now? Okay, awesome. Okay. So these are a little bit more challenging, and it doesn't really matter. This Fred and Barney one here, I've got two examples, and then we'll talk about the difference. Okay, Nate, you need to put that away. I need your attention. 100% concentration today. Oh, and I really should have brought my notes, shouldn't I? Do you think I can do this without my notes as a crutch? I'm kind of nervous. Oh, yeah? Okay. Well, let me see if I can do it from memory here. So I got Fred and Barney. It doesn't matter which one's which. We'll label this one Fred here. Barney. Don't know if you guys are Flintstones fans or even if you know who the Flintstones are, but that's what it says in the book. Fred and Barney are at opposite ends of a 1 kilometer long drag strip. Right away, change that to 1,000 meters. Like, don't even think about it, right? It's going to be in meters. And they're matching race cars. Fred accelerates from rest toward Barney at a constant 2 meters per second squared. So his acceleration is 2. And his initial velocity is 0. Barney travels toward Fred at a constant speed of 10 meters per second. So he's got an initial speed. His VI is 10. And his acceleration is 0. How much time elapses until they collide? So we're solving for t. I need to orient here, so give me a second. Apparently this has to be done every day. That's actually correct, yes. Yeah, so, yeah, it's constant, so in fact it's V bar. Right you are. Hello, Mustafa. Now, is there any other information that's implied in this problem that we're not specifically given? Like sometimes you have to assume gravity is minus 9.8, but that's not the case here because we're not talking vertical, right? He travels towards Fred at a constant speed of 10. The question was, how do we know his acceleration is 0? So because it's a constant speed, it's 10. There's no acceleration. Constant speed means there's no acceleration, right? Okay. There is one piece of implied, this is from yesterday, Mustafa, the same sheet. There is one piece of information that's implied that isn't specifically given to you, and that is, when do they collide? When their positions are the same. That's when two objects collide, right? When their positions are the same. So somewhere in the middle there's going to be a collision, right? Now, their position at the start is different. What is Fred's position compared to Barney's? Well, he's here. Barney's way over there at a kilometer away, right? We should assign one of them 0. So we're going to say Fred is equal to position 0. And way over here, Barney, what's his initial position? And should we maybe say plus 1,000 just to specifically specify that it's to the right? I don't, because I said specifically specify, and I don't think you need to say that. It's kind of redundant. It's kind of like saying redundancy over and over again. Okay, I'm also kind of stalling here while I'm thinking about the next step. Did you notice? Still stalling. Okay. So their positions are dependent upon their displacement, right? Like his position later is going to be based on his displacement, but Barney's position is his displacement is to the left, right? That says plus 1,000. So he's at an initial position of plus 1,000. Because Fred is at 0, and Barney's over here to the right. Does Barney have to be to the right? No, it could be the other way, right? Doesn't really matter. Okay. So the positions are Fred's position. I'm going to say PF is equal to displacement of Fred. Because he starts at position 0, whatever his displacement is, like if his displacement is, say, plus 15, he's then at a position of plus 15, right? So position Fred, PF, is equal to displacement Fred, displacement. We are given initial velocity, we're giving acceleration. How do we find displacement given acceleration and velocity? And we don't know the time, by the way. What formula do we know? Well, we know D equals VIT plus 1/2 AT squared. But we don't know the time. Right? Do we know his initial velocity? 0, so that drops off. So we're going to say position Fred is equal to the displacement. VIT drops off because the VI is 0. 1/2 AT squared, so that's going to be 1/2. His acceleration was conveniently 2 times t squared, which we don't know. 1/2 of 2 is just 1. So ultimately, Fred's position, PF, is equal to t squared. Right? He's at position whatever. If the time is, say, 3 squared is 9. At 3 seconds, he's at position 9. I went 1/2 times 2 is 1. Okay, so now we got to do the same thing for Barney. Barney's a little bit different. Okay, position Barney, I'll do it in a different color here just to separate it. Position Barney is actually his starting position. Position Fred is the starting position plus the displacement, but because the starting position was 0, we kind of ignored it. Barney's starting position is 1,000. And I'm going to add displacement Barney. The same was true for Fred. We just ignored the starting position because it was 0. The displacement is negative. So it's going to be 1,000. What's the displacement at a constant velocity? What's the formula? Anyone know? You do. You're just not willing to say it. Isn't it not just V bar times T? If he's going, what's his speed? I can't see up there. 10, right? Yeah. He's going 10. After 2 seconds, he's gone 20 meters. After 3 seconds, he's gone 30, right? So it's just 1,000 plus V bar times T. And because it's 10 to the left, it's going to be minus 10T. Position Barney, PB, not to be confused with peanut butter, is 1,000 minus 10T. So I've come up with specific individualized formulas for Barney's position and Fred's position. Okay, when do they collide, Sam? Not time-wise. When they're at the same position. So how are we going to find that? We're going to set position Fred equal to position Barney. I'll go in a different color. And I'll make more room. It's a big question. So when do they collide? When PF is equal to PB. That's an equal sign. When the position of Fred is equal to the position of Barney, they collide. No, I know. This is new. There's no doubt about that, right? This is a new sort of thought process. The formulas aren't new, but just how we're putting it together is. No, position actually equals original position plus displacement, which is what I did over here in Barney. Nate asked us position always equal to displacement. Position Barney is 1,000 plus displacement Barney because he starts at position 0, or position 1,000. Fred started at position 0, so I didn't need to do that, right? Right. Okay, so now that I've got them equal to each other, I take their corresponding version. So PF is T squared And PB is 1,000 minus 10t. And what have I done? I've created an equation that only has one variable, the letter t. But you all just realized that what kind of equation is it going to be? Quadratic. You mean hooray. I like my t squareds positive. I'm sure you do too. Okay, so let's bring everything to the left. So it's going to be t squared. Bring the t over first. Minus 10t is going to become plus 10t. So plus 1,000 is going to come over to the left and become minus 1,000. And the whole thing equals?
Still keeping it on the right side.
Okay, I don't care. No, it doesn't, but I had t squared on the left, so that's why we went that left. It always is, but it might be decimals. It feels like it should be factorable, shouldn't it? But factors of 1,000 that add or subtract at only 10.
Down.
So you'd have, like, just for fun, we'd have 1,001, 502. They got to add up to 10, not 498. 250 and 4. No, I just scribbled it, that's all. 205. I'm not 195. I got to get to 10. Just do the formula, yeah. Well, 3 doesn't go into 1,000 evenly. Like 150. I don't know. It just like Billy says, just do the formula. It will be. You'll see there is factors, but there are 2 that you would never ever come up with. Yeah, you go. You go stand in the corner and factor and stuff. Okay, so quadratic formula. Can I write t equals? Is that okay, or do you feel like you have to write x equals? I always feel like I have to write x equals, but I'm going to try to get into the habit this year of doing it this way. So t is equal to minus b plus or minus square root b squared minus 4ac all over. You know, I'm pretty proud of myself. I think I'm going to solve this without any notes in front of me. Whey. Yeah, whey protein. No, like Little Miss Muffet, curds and whey, that one. Is that the same stuff? Whey protein and what Little Miss Muffet was eating? I think it is, yeah. Oh, yeah, right. Back in the day. What are you, 17 years old?
All you ate was beans.
That would explain a lot, Nate. Minus b, I should have left my equation up there, right? Minus b is going to be minus 10 plus or minus square root b squared is going to be 10 squared minus 4. A is only 1. C is what's the number in front of t squared? 1. 1. There's no number, it's 1. 2a, all over 2a is 2 times 1. How much of this can I do in my head? 4 times 1 is 4 times 1,000, 4,000, so it's going to be 10 squared is 100 plus 4,000. I think the whole thing works out to 4,100, right? 4 times 1 is 4 times 1,000 is 4,000. It's plus because of the 2 negatives, so we got plus 4,000. 10 squared is 100. 100 plus 4,000 is 4,100. All over 2. I'm like some sort of mathematical genius, right, Nate? Yeah, whatever. Okay, square root 4,100. I can't do that in my head, sorry. Once you tell me the number, I'll remember it because I've done this problem 1,000 times. What's my guess? No, well, he said 60, but 60 exactly? That doesn't make sense. 64.03. Okay. So minus 10 plus or minus 60, 60.4? 64.03. All over 2. Okay. Now, is there always going to be a positive and a negative answer? Yes. Figure out which one's going to be negative and just ignore it. Okay? The whole thing is over a plus 2, so the top has to be positive for the whole thing to be positive, right? So minus 10 minus 64 is going to give me a negative number. That's going to give me negative. So don't do that one. Minus 10 plus 64 is 54 all over 2, which is whatever, 27 seconds. The other value, I remember it now, is minus 37. And if you did multiply those together, you get real close to 1,000. It's not really factorable unless you get some decimal place in there, yeah. So it takes a whopping... No, actually, I would prefer actually that you recognize the one's going to be negative and just ignore it. I really would. Solve for t, 27 seconds. What was the actual question? How much time elapses until they collide? So it takes 27 seconds. Like 10 meters per second, that's what Barney's doing. His race car, it's probably like a, built with like a snowblower, 2 horsepower snowblower motor or something rather, because 10 meters per second is like, 36 kilometers an hour, top speed. I've seen Billy run faster than that.
No way. Look at Salt Lakes over there.
He might have hopped over a few guys during that time that he was running.
Rugby is a funny setup. I never usually try hopping over someone. That's like,
What is that, illegal in rugby, hopping over people? What are you talking about? You can't. Seriously? You can't?
rugby's everything's gets wrong. Yeah. They wear some PKK.
Oh, well, okay.
You
You like jumping over guys, don't you? That's true. Okay. Let's have a look at example 13 here. This time, let's have a read of the question and see if we can. I'm going to let you guys try this. I'm going to give you some time to try. But let's just sort of get you started here. Jack is running at 6 meters per second to catch a bus.
Wow. This guy's so fast.
Well, he's wearing a suit and it's slippery out. Oh, jeez. Can I do that? Don't show it to me again. Okay, so Jack's catching the bus, or trying to catch a bus. He sees it start to move when he's 20 meters away. So this distance in here is 20 meters. The bus accelerates at 1 meters per second squared because it's speeding up. Will Jack overtake it? Will he catch the bus? If so, how long will it take him? What's the big difference between this one and Fred and Barney? They're going in the same direction. Does it matter? Does anything matter with that? Like, does it matter? The only thing is, if I could go back one page, right? Barney's position was 1,000 plus dB, and it was because it's negative t that it's, right? If this becomes positive right here, what happens? Barney's going the other way, right? So that's the only difference, is that sign right there. Can I erase just green? No. Okay, so set it up exactly the same way. Figure out position. Figure out a formula for the position of Jack. Figure out a formula for the position of the bus. In both cases, it's starting position plus displacement. Well, we have to, there's been no definition, or it hasn't been told to us, right? So you could theoretically say, set the bus to 0, and then Jack would be at minus 20, right? You could do it that way. Most people would intuitively make the one on the left equal to 0. And this would be plus 20. Yes, Jack is running at a constant 6. He's already accelerated. He can't go any faster. Yes. Okay, so I'm going to give you about 5 minutes to try that, and then I'm going to do it. Okay, so give that a whirl. Base it on the last one. I wanted to give you a little chance to try. Okay, fair enough. That's okay. Some people may have been okay. That's okay. We'll help you here. Okay, so Jack's position is his initial position plus his displacement. Jack is moving at a constant velocity. So it's just going to, do I need to write the 0? No. Displacement is either accelerated displacement or constant velocity. Jack is moving at a constant 6, so it's just v bar times t, isn't it? 6t. Position Jack is 6 times t. After 1 second, he's at position 6. He's only got 14 meters to go, right? Because the bus is moving. Right? The bus is... Oh.
That's cool.
Oh. Jack ain't ever catching the bus that way, is he? No. Okay. Okay, position bus. I'm going to need more room here. Position bus is the initial position, which is 20. The displacement of the bus is accelerating. What is its initial velocity? VIT plus 1/2 AT squared, but fortunately, the initial velocity of the bus is 0. So the VIT drops out. 1/2, the bus's acceleration is 1 t squared. 1/2 of 1 times t squared. Last time it was 2, so it kind of disappeared, but here it's a half. So it's going to be 20 plus 1/2 of 1 is? Yeah, 0.5 t squared. That is position bus. So what's the next step? Set position Jack equal to position bus. Put it all onto one side and solve. You're going to set, you're going to set this equal to this, right? Do you want me to write it out? Do you want me to just keep going?
Yes.
Sure. 1 minute. Not far enough, right? And you're not going to get any farther. Yeah. So we're going to set them equal to each other. It would be real nice if you showed me position Jack. That's a PJ. That's a really bad J. Start again. Position Jack is equal to position bus. That's when Jack catches the bus. And position Jack is 6t, and the position of the bus is 20 plus 0.5 t squared. And again, everybody in the world loves it when the squared one is positive. No one likes a negative there. I don't know why. It just doesn't feel right. So I'm going to go 0 equals, this time we're going to go to the right just to help Nate out. I like to put the t squared first. I'm sure you do too. Why is that a good idea to put the t squared first? So you get your ABCs right. Cole, put the phone down, man. Come on. I could come up with a smart answer, but I think I'll just keep going. 0.5 t squared. Now I want my t next, right? So 6t is going to become what, Sam? Negative 6t. Put the phone down, you guys. Holy moly. Minus 6t plus 20, right? Now solve, Mustafa. That's factorable. Well, you like factoring, don't you? I'm not even going to attempt it unless that number in front of the t squared is 1. You can divide it out, factor it out? Is that what you want to do? Okay. Oh, but it can be done. Okay, we're going to go on a detour here. Tyler wants to go. 0 equals, we're going to take a half, 0.5 out. He really wants to factor. So t squared, divide by a half, minus 12, right? Don't make that mistake when you divide out by a half. 20 divided by a half is going to be? Divide by a half. So factors of 40 that add up to 12, Mustafa. Add up to negative 12. I agree, man. Huh? I ain't factoring Mustafa. You know why I'm not factoring it? Because I know the answer. I know the answer. Cole, am I still good with? Am I following your path? Because I want to make sure here, because I know that what you said is important. So, t equals quadratic formula minus b plus or minus square root b squared 4ac. And the reason that we include this question is very specific, and you're going to find out real soon. The big reveal is coming here. So minus b is 6 plus or minus square root. B squared is going to be minus 6 squared. Can I just write 36 in there? You okay with that? No, I'm not allowed to, Nate. 36 minus 4ac. A is 0.5. C is 20. A is 0.5. Am I still good, Cole? Still with you? It's all over 1. Yeah, 2 times 0.5 is all over 1. Okay, so minus 4 times a half, that's minus 2. Oh, there is something wrong here, Mr. Bennett. Oh, no, I'm good. I'm good. My mistake. 4 times a half is minus 2 times 20 is minus 40. So I got and what happens, Cole? It's not. We're not even before that. It's 6 plus or minus the square root of minus 4 all over 1. What does it mean? No. What does it mean? He doesn't catch the bus. There is no solution. There is no 0. There is never a time. This is an awesome question. I love this one. There is no time that position Jack is equal to position bus because Jack never catches the bus. The only way is if Jack turns into like imaginary numbers, right, or something rather, and then imaginary world where he imagines that he catches the bus. Something. There is no answer. He does not catch the bus.
Do you teach standard physics?
I taught him grade 11.
Really?
Yeah.
How's that? I thought you know a lot to. I thought parents aren't allowed to teach your kids in school.
Did you see that written down somewhere, or just? Yeah, absolutely. I probably helped you more than I helped him. He actually did. Yeah, he did do pretty well at this. Okay, so there's your 2 ones where they collide. There are some in the book. They're at the latter part of that. I gave you those answers yesterday, or the question numbers yesterday. I didn't bring my sheet, so hopefully you have that from yesterday. The plan is this. Today is Wednesday, right? Time we got. Okay, so I'm going to give you the rest of this period to work on problems. Tomorrow is. Oh, it is Tuesday. Oh yeah. Oh, I got my days right. Friday, there's no. Yes. It's Tuesday. There's no Friday. No school Friday. So you get the rest of this period to work. Wednesday will be a work period. Little quizorama on Friday. 3 questions. Nothing new. 3 questions. All kinematics problems. And it's not for marks, it's just, are you ready for the test? That's all it is. There will be 1, I believe. One of them will be a quadratic. I would like to start vectors on Monday. That's the plan. Vectors. Probably like end of next week. Is next week a 4-day week or a 5-day week? I think it's a solid 5 days, right? Okay, so probably, Thursday or Friday next week will be the first test. Alrighty. Enjoy. Hello. Okay. Or you know what? I've already sent it out. You do it when you want. There's no answers on the back, so you're on your own on it. Just do it. It's not for marks, so it's just a check to see where you're at. So. Okay. Have fun. Enjoy.